I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. We'll understand arithmetic sequence, use common difference explicit formula, recursive formula, and then apply them to practice some examples. You can register for my classes by sending an email. These are the courses which are being offered this year. Our approach, engaging minds, really help you to bridge the gap and apply the concepts learned. See how, in steps, we'll develop the strategies and apply them in solving these examination questions. In case you want to learn from me, you can always send an email on the address given. Gain confidence and get ready for the future. Let's begin with the class now with Rohan. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So Rohan, today what do you want to learn?
Sir, today I'd like to learn discrete functions.
Okay. So let me just share with you a whiteboard and then we'll discuss discrete functions. What do you understand by discrete functions? Can you tell me?
So in discrete functions, what I understand is that there's two different kinds of sequences in discrete functions. One is arithmetic sequences and the other is geometric.
Right. In your book, there are two chapters, arithmetic sequence, geometric sequence. Then they talk about arithmetic series and geometric series. Perfect. But when we come back to discrete functions, what does it really mean? So it's definitely a function. That means for different values of x, you have some values of f, right?
Yes, sir.
And these values are discrete means you cannot connect them with a continuous line. You understand?
Okay, sir.
So that is discrete values. That means they might have some integer values, maybe some whole numbers, but they are not all real numbers. Means they may follow a particular pattern, but you cannot connect them with a solid line, right? So cannot be connected by a solid line. On a graph. Do you understand now? This is the
Yes,
basic.
sir.
So we are saying that the value of x is not all real numbers, right? So x belongs to, let us say, most of the time we say x belongs to natural numbers, or we say x belongs to integers. So these are discrete values. Is it okay? They are not continuous values. So we will not say, so x does not belong to real numbers. You understand?
Okay, sir. Not like we've been doing before, right, sir?
Yeah. So normally, let's say if I have an equation y equals to 2x plus, let's say, 1, it really means that you will take some values of x. You may take x equals to 0, 1, 2, 3, and so on. And for these values of x, you calculate the y values. And you may guess something like this. You see the graph now,
Yes, sir.
right? So something like this. Such graph you could be connected with a dotted line, not a continuous line. So this is the basic concept which you should keep in mind when we're talking about discrete functions. Is it okay?
Okay, sir.
Okay. Now let's look into what is arithmetic sequence. Sequences which have common difference are arithmetic sequences. That is to say, let me give an example. Let's say we have 1, 3, 5, 7, correct? You see, each number is increasing by 2, right?
Yes, sir.
So that is an arithmetic sequence. We could have a sequence like decreasing by a fixed amount. Let's say in this case, 3, right? So in this case, as you can see, each number decreases by 3. Both are examples of arithmetic sequence. Now in sequence, in general, what we are trying to say, common difference. Let this common difference be D. And let's call, these are called the terms. This is the first term. This is the second term. This is the third term, and so on, right? In general, we'll have nth term. Any term, right?
So would we express first term as A when doing it
Could
if we
say,
express it as D?
you can say first term in the books, normally, we say A. So when I say common difference is D, then, of course, my arithmetic sequence will look like this. A, add D each time. Do you see this? Again,
Yes, sir.
if I add D, it becomes 2D. A plus 3D. Do you see that? So, you know, this is, which is this term number? Can you write down the term number?
Third term or term 3?
Fourth term. Do you see that?
Oh, because if we considered A as first term, then that's how we would consider other two terms.
Yeah. Do you see that? So do you see the term numbers, right? So can you tell me what will be the nth term? A plus how many D's?
A plus n minus 1D.
Correct. So nth term will have A plus n minus 1D. You get the idea?
Yes, sir.
That becomes the nth term. So we have come across the very first formula, that is nth term. We'll write this as Tn. Subscript n means nth term. This means nth term is A, the first term, plus n minus 1D. Is that clear to you?
Yes, sir.
We got the term number formula also for arithmetic sequence. Now, let's take some examples. Let's say we start with number 3 and we have these numbers. Can you find the 10th term in this?
Sir, would it be T of 10 is equal to 37?
So you plug this value, first term being A, common difference being 4. You want the 10th term. That means 9 fours will be added, right?
Yeah. So that would be 36 plus.
So you know the 10th term will be 39. Correct? Now, normally, what we have, like we have this particular formula. So we could actually simplified form, the formula will be what? Let's now write down a simplified formula. For the nth term, we know here it is 3 plus n minus 1 times 4, right? Because 4 is the common difference. So instead of d, I'll write 4 here. If I open this bracket, I get 3 plus 4n minus 4, which is 4n plus 3 minus 4, or 4n minus 1. So my general formula can be simplified and written as Tn equals to 4n minus 1, correct?
Yes, sir.
So that becomes our general formula. Now, you can use the formula, write down the values for a and d. A, you know, is 3, d equals to 4, and then simplify and get the result. All right?
Yes, sir.
Let me show you a shortcut method. Now, in this particular case, you see you are adding 4 each time. How many 4s do you add? One less than the number n, right?
Yeah.
Adding 4s multiple times really means multiplying by 4 those many, right?
Yes, sir.
So that means multiplication of 4 should be part of the formula, right? Makes
Yeah.
sense. So now, so I could say 4n is my formula. Then, but you know, this is my first term, right? This is T1. T1 is 3. 1 times 4 is 4, not 3. How do I get 3? I have to take away 1 to get 3. You see how easy it is?
Yes, sir.
And you get the formula without doing all this. You get the idea.
Okay, sir.
Let me take another example to illustrate. Example 2. So let's write down, this is 7, and then let's add 5 to it, right? 7, 12, and then 17, 22, 27, and so on. Can you give me the general formula Tn? We know it is being added by 5, right?
5.
So generally you will say a plus n minus 1 times d, which is 7 plus n minus 1 times 5. And then you will simplify. What will you write? Well, 5 times 1 is how much?
5.
How do you get 7?
Adding 2.
It should be that. You see that?
Yes, sir.
So we could get straight away without doing this. And of course, if we continue with this calculation, we do get 5n minus 5, which is 5n plus 7 minus 5, which is 5n plus 2. Same, right?
Yes, sir.
So the idea here is to understand how do we quickly get this particular formula. Now this formula, if I want to know what is the 100th term, you'll put t 5 times 100 plus 2. Easy, right?
Yeah, so be 502.
So this formula is called explicit formula. Explicit formula gives you direct result. All the formulae which we normally use for calculating are explicit formula, right? You're given some values. If the radius is 10, what is the area of the circle? Correct? You write pi r squared, direct answer. Correct?
Yes, sir.
Now in this pattern, we also see another kind of formula, which is called recursive formula. Means what repeats? Recursive formula, right? So let me go to a fresh page and we'll talk about recursive formula. So the recursive formula, in this case, let's take another example, right? 3 plus, let's add 2, right? 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 11, and so on, correct?
Yes, sir.
So you can say my term number 1 is 3, and so the next term, we can say Tn is, what are you doing? You're adding 2 each time, right?
Yeah.
So Tn minus 1, previous term plus 2. So add 2 to previous term, right? Repeat. So that becomes a recursive formula.
Okay, sir. So for an example, if we were to plug in t of 5, so it'll just be t of 4 plus 2, which is 11.
Yeah, now because you have to find all the terms, right? You get the idea.
Yes, sir.
So you have to find. So what is T of 2 equals to? You say T of 2 will be T of 1 plus 2, which is 3
It's
plus
3.
2, which is 5, right? Then you say T of 3 is T of 2 plus 2, which is 5 plus 2, which is 7. Do you see the method of doing it?
Yes, sir.
Keep on adding, right? Then that means you have to find all the following. To get the following, you have to repeat this process, correct? So you have to repeat this process and continue. That is how the recursive formula works, correct? So we
Yes,
do
sir.
have questions where we may be given one formula and we may have to find a general formula or a recursive formula or something else, correct? Let's take
Okay,
an
sir.
example. So let's say I'm given, let's say example 3. Let's say my T1 is, let's say some number, let's say 4, and Tn is Tn minus 1 minus, let us say 3, correct? Find T10. So how will you find T10?
So the way that in order to find T10 would be by finding the previous numbers. So by already understanding Tn is minus 1 and T1 is already equal to 4, we can substitute T of 2 to get 1 as T of 2, and then doing it again and again to reach T10.
Correct. Or you could say that is your recursive formula, right? You kind of make a table, for example, right? First term is 4 and then you do minus 3, right? Second term you do minus 3, correct? So you
Yes, sir.
come to 1 and then third term will be minus 3, right? So minus 2, fourth term will be minus 5. Like this you can continue, correct? Which is a
Yes, sir.
long process. You could do that. Another way could be that you can now write from here method 2. You know A is 4 and difference is minus 3, correct? Because you're subtracting 3 each time, correct? So Tn will be directly written as 4 plus n minus 1 times d. D is known to you as minus 3, right? 4 plus n minus 1 times minus 3. And you can open the bracket, 4 minus 3n plus 3. And you get minus 3n plus 7. So T of 10 will be minus 3 times 10 plus 7, correct? Which is minus 30 plus 7 or 20.
Negative 23.
Do you see that?
Yes, sir.
So you could get the answer directly like this. Does it make sense to you?
Yes, sir.
Very good. I'll teach you third method, which is not there in any book. So again, let's say we have a sequence. Let's say we begin by number, let's say 6, right? And we keep on adding, let's say 4 to it, right? So get 10, 14, 18, 22, and so on, correct? Now, with your knowledge, you know, here the common difference is plus 4, right? You're adding 4 each time. And your shortcut method 2, so you know method 1. Let's write method 1. Method 1 will be 6 plus, we are trying to find Tn, right? N minus 1 times 4, which will give you 6 plus 4n minus 4, which will give you 4n plus 2, correct?
Yes, sir.
Method 2, you know, because 4 is the multiple, and you say 4 times 1 is how much? 4 times 1 is 4. To get 6, I'll have to add 2, right? So you could directly write 4n plus 2, correct? Right?
Yes, sir.
Now method 3. You know equation of a line? Because you see this pattern follows a linear pattern, right? So it's linear pattern. As first difference is constant, correct? So I could use the line y equals to mx plus b, correct? Where m is the rate of change, by how much is it changing? It is changing by 4 in this case, right?
Yes, sir.
To find b, b is the value when x is 0, right?
Yeah.
So I have to go backwards because this is at 1, right? This is at 2. So if I go backwards, I'll do minus 4. If I do minus 4 to 6, I get 2, right?
Yeah.
So b equals to 2. I will substitute 4 for x, m, 4x plus 2, I get my result using this line. Do you see that? I can go back one step, get the kind of y-intercept, the initial value was 0 from where you could have started. You get the idea?
Yes, sir. So basically, all the three methods both give you the same answer, right, sir? Like
Yes.
the same formula that can be.
So depending on the situations, you might find these methods very useful. You get the idea?
Yes, sir.
We are always, you'll find in your batch, in your class, everybody in the class will always be going forward and then they will go calculate and get the answer. Why not go back and get the y-intercept kind of? You see that? So
Sir.
0th term is minus 4 of this value, which is 2. And therefore, I could directly get this value 2. And 4 I got from the common difference. So I have my formula. You see that?
Yes, sir.
Very, very beautiful method. How does it help you a lot? It does really help us. Let's say we have an auditorium, right? Where there are seats like this. Correct? Let's say in the first row, there are 7 persons. This is my first row, okay? In the second row, in each row, we have 4 more. Correct? Let's say
So
7.
11
So tell me, how many will be there in the 20th row?
in the 20th row, right, sir?
Yeah, it is increasing by 4, right?
Yeah.
So which method
So
will you do?
couldn't we just use the first method or the third method? So
Third
if we use the first method, we would just,
method is 0th row, right? So
yeah.
instead of adding 4, if I subtract 4 to 7, I get 3, right?
Yes, sir.
And I know it is increasing by 4, and therefore my general term will be 4 times n and the first value 3. Do you see
Plus
how
3.
easy I got without any calculation?
Yes, sir.
You see that part? Very easily I got my answer. I subtracted, right? And then I know 20, right? So I'll say T20 will be 4 times 20, which is 80, plus 3, 83. So 83 persons in the 20th row. Perfect.
Yes, sir.
So this is a very, very fast way of calculating. Instead of taking D and going up, you can think about coming back to 0, the initial point. Instead of 1, go to 0, so that you get the y-intercept, and then y equals to mx plus b concept. You see how we applied the learned concept in this context. That is what I'm trying to focus on.
Yes, sir. So I understood how you were able to automatically get the same answer in the third method instead of doing multiple step calculations in the first method and second method.
Very good. Beautiful. You loved it, right? All the students who will do this. For example, our arithmetic sequence will be something like this, a graph which will have these values. Do you see that?
Yes, sir.
All these numbers are given for 1, second term, third term. These are term numbers, right?
Yeah.
And these are term values. Correct? And for each, we know this rate of increase, correct? how much is it increasing by, right? Let's say this is your D. Do you see that? Increasing
Yes,
by
sir.
D each time. What we are trying to do is we come down, right? We do minus D and come to this point.
Okay.
This is our B, right? And
Yeah.
therefore, we could apply the formula y equals to mx plus b, where m is the common difference D, right? Do you see that?
Yeah.
And B is A minus D.
Okay, sir.
B is A minus D. See that?
Yeah.
A minus D. And now look at your problem, right? We had this 7 people here, and we have 11, right? Increasing by 4, correct?
Yes, sir.
So we know D is 4 and A is 7. And therefore B is how much? B is A minus
Then
D.
B would be 3.
You see A minus D.
Yes, sir.
You see how easily we got a formula for the term value in arithmetic sequence. That's the beauty of this formula. You have all of a sudden connected your knowledge of linear equations with arithmetic sequence, and that is going to help you solve any question very fast.
Okay, sir.
You understand?
Yeah.
That's the beauty, right? Let's take up some example. Let's say we say that the fourth term for us is, let us say 20, right? And let's say the 10th term is, let's say 38, correct? Can you
Yeah.
find 20th term? And
Find the 20th term.
sequence, yes. How will you do this question?
So if there's 2 different terms in that, so what we have to do is you have to create 2 different equations
Yes, yes.
to find out the base value, right, sir?
Write down and find, correct. So
So
general Tn is A plus n minus 1 times D, right? We don't know A, we don't know D. So we can say T4 equals to, A is not known to us, 4 minus 1 is 3D, right?
yeah.
And that is 20. Similarly, we have A plus 9D equals to 38, correct? So we got 2 equations. Do you see that?
Yes, sir.
Yeah, use these equations, find your answer, please.
So substituting them in, so if we do, so 2 minus 1, so it should be A plus 9D, 38 subtracted by A minus 3D equal to 20, which would then just be, so AA cancel, so that's 6D is equal to 18, D must be equal to 3. So then sub that into the first equation. So then we should just get A plus 9 is equal to 20, where A should be equal to 11.
So you got the answer?
Yes, sir.
What is your answer?
A is equal to 11.
20 minus 9, right?
Yeah.
Correct. A is 11. So you know D is 3, right?
Yeah.
T20 you can now
So
write.
if it's 20, then all we can just do is use the same equation and substitute 11 into it.
You love this? This is the most difficult question in the book. You know that?
Oh,
And you just answered it without any problem, correct?
yes, sir.
So try to do the exercise from the book. In case there is any difficulty, get back to me. Let's see then, okay?
Okay, sir.
Okay then, all the best. We'll end our
Goodbye, sir.
Bye, all the best.